Titan, Saturn's largest moon, shrouded in a thick orange haze, beckons us with its mysteries. Titan is larger than our moon, and even Mercury, a true giant among moons. Its surface is dotted with lakes and rivers, but they're filled with liquid methane, not water. Perpetual twilight reigns and the air is a toxic mix of nitrogen and methane. Titan's thick atmosphere, rich in organic molecules, offers a glimpse into our planet's ancient past. It's a world ripe for exploration, and perhaps for discovering the origins of life. For over a decade, NASA's intrepid Cassini spacecraft graced the Saturnian system, unveiling the wonders of the ringed planet and its many moons. Among its many targets, Titan held a special allure. Cassini's instruments pierced through the moon's hazy veil, revealing the secrets hidden beneath. Radar images from Cassini unveiled a world sculpted by familiar processes: erosion, wind, and maybe even volcanic activity. But the most striking revelation was the discovery of vast, smooth plains, regions that hinted at the presence of something truly extraordinary: lakes and seas. Scientists had long speculated about the possibility of liquid on Titan's surface. The chemical composition of its atmosphere, rich in methane and ethane, suggested that these compounds could exist in liquid form under Titan's frigid conditions. But it was Cassini that provided the irrefutable evidence. Titan was a world with not just one, but hundreds of lakes and seas. These bodies of liquid, however, were not the placid, mirror-like surfaces one might imagine. As Cassini continued its observations, it sent back data that left scientists baffled and intrigued. The lakes of Titan were not so still after all. Something strange and unexpected was happening on their surfaces. As Cassini beamed back its trove of data, scientists eagerly pored over the images, expecting to see smooth, undisturbed surfaces on Titan's lakes. After all, Titan's dense atmosphere and low gravity suggested a relatively calm environment. But what they found was something far more intriguing. In the radar images, bright transient features appeared and disappeared on the lake's surfaces. These features, dubbed magic islands, seemed to defy explanation. They appeared as small, island-like formations, but their ephemeral nature suggested they were something altogether different. Were they floating chunks of ice, or perhaps bubbles of gas rising from the depths? The mystery deepened as scientists struggled to reconcile these observations with their understanding of Titan's environment. The magic islands became a subject of intense debate and speculation. The answer, it turned out, lay not in exotic materials or geological processes, but in something far more familiar. Waves, yes, waves. Ripples on the surfaces of Titan's alien seas. But how could this be possible in a place as cold, calm, and seemingly inhospitable as Titan? Waves on Earth are a product of wind, the friction of air moving over the water's surface. But Titan's atmosphere, though dense, was thought to be relatively still. Its low gravity also meant that winds would need to be significantly stronger to generate waves on its thick, viscous lakes of methane and ethane. The very nature of these liquids posed another challenge. Methane and ethane are far less dense than water. This means that waves on Titanian lakes would behave differently, likely being larger and moving more slowly than their counterparts on Earth. The frigid temperatures added another layer of complexity. At Titan's surface, temperatures hover around -180 degrees Celsius or -292 degrees Fahrenheit. These extreme conditions meant that any waves generated would encounter significant resistance from the thick, slushy consistency of the liquid methane and ethane. Given these factors, the presence of waves on Titan's lakes seemed improbable, if not impossible. Yet, the evidence was right there in the Cassini data. The magic islands were most likely the crests of waves, their transient nature a testament to the dynamic nature of Titan's seemingly placid lakes. If the so-called magic islands were, in fact, waves, what could possibly be causing them? This question really sent scientists on a quest to unravel the forces at play on Titan's enigmatic surface. Several theories emerged, each offering a plausible explanation for the ripples that were observed. One possibility was seasonal winds. Now, even though Titan's atmosphere was generally thought to be pretty calm, there was actually some evidence of seasonal changes and the potential for stronger winds during certain times of the year. These winds, though still relatively weak compared to what we experience on Earth, might be just enough to stir up the surfaces of Titan's lakes, generating small ripples. Another intriguing possibility was the release of gas from beneath the surface. Titan's subsurface is believed to harbor vast reserves of liquid methane and ethane, and it's conceivable that gas bubbles could rise up through the lakes, creating disturbances on the surface. These disturbances, while not technically waves in the traditional sense, could definitely look similar in radar images. And then there's subsurface activity like cryovolcanism, basically volcanoes that erupt with ice and other volatile compounds instead of molten rock. While there wasn't any direct evidence of cryovolcanism near the observed ripples, it still remained a tantalizing possibility, hinting at a more dynamic and geologically active Titan than scientists had previously imagined. The discovery of ripples on Titan's lakes sent ripples of excitement through the scientific community. It was a finding that, honestly, challenged preconceived notions and opened up new avenues of exploration. It showed that Titan, despite its alien nature, was a world shaped by dynamic processes that could have big implications for our understanding of planetary evolution and the search for life beyond Earth. The presence of waves, even if they're small, confirmed that Titan's lakes were not just stagnant pools of hydrocarbons. They were active environments, subject to forces that could stir their depths, potentially moving nutrients around and creating habitats that might be more suitable for life. Though Titan's methane-rich lakes are really different from Earth's oceans, they offer a unique testing ground for our understanding of how life can arise and survive in extreme environments. The discovery of ripples hinted at a world that was way more complex and dynamic than we had previously imagined. A world that could hold surprises far beyond what we currently understand. These findings, well, they fueled the anticipation for future missions to Titan, missions that would dig even deeper into the mysteries of this enigmatic moon. And on the horizon, a new mission promised to unveil Titan's secrets like never before. Dragonfly. Inspired by the tantalizing discoveries of Cassini, NASA decided to embark on a new mission to further unravel Titan's secrets, Dragonfly. This ambitious mission, which is slated for launch in the late 2020s, aims to send a rotorcraft lander to explore Titan's surface and atmosphere. Dragonfly, as the name suggests, would actually take to the skies of Titan, hopping from one location to another, covering vast distances and exploring all kinds of terrains. This unique mobility would allow Dragonfly to sample Titan's atmosphere, study its surface composition, and even check out potential landing sites near those intriguing lakes. Equipped with a suite of sophisticated instruments, Dragonfly would search for signs of past or present life, study the chemistry of Titan's atmosphere and surface, and investigate the moon's fascinating methane cycle. It would be our eyes and ears on this alien world, sending back data that could really revolutionize our understanding of this mysterious moon. The mission promised to be a real game-changer, offering an unprecedented glimpse into a world that has captivated scientists and dreamers alike for decades. Dragonfly represents the next bold step in our exploration of Titan, a journey right into the heart of a world that might just rewrite our understanding of life in the cosmos. As Dragonfly gets ready for its epic journey, the mysteries of Titan's lakes continue to call out to us. The ripples that Cassini observed are really just a glimpse into the complex processes shaping this alien world. So what other secrets might be hidden beneath the hazy veil of Titan's atmosphere? Could there be more to the so-called magic islands than meets the eye? Maybe they're evidence of even more dynamic processes, like underwater currents or, who knows, even forms of life that thrive in Titan's hydrocarbon seas. The possibilities here are as vast and mysterious as Titan itself. Titan challenges our very definition of what a habitable world can be. It reminds us that life, if it exists elsewhere in the cosmos, might take forms that are totally different from what we find on Earth. It really compels us to expand our horizons, to embrace the unknown, and to explore with open minds and a genuine sense of wonder. The exploration of Titan is a testament to the power of human curiosity, our deep desire to push the boundaries of knowledge and venture into the great unknown. It's a journey driven by the thrill of discovery and the quest to answer some of humanity's most profound questions. Are we alone in the universe? And what other wonders are waiting for us among the stars? As we stand on the edge of a new era of exploration, Titan reminds us of the vastness and wonder of the cosmos. Its mysterious lakes and ripples challenge our assumptions and ignite our imaginations. Titan is a microcosm of the universe, full of mystery, wonder, and endless possibilities. Our journey of discovery is far from over, inspiring us to keep exploring and seeking our place in the cosmos.